Our next speaker for today, we have Mr. Kalyan Dhokte, Practice Head Digital Engineering from Cognizant. Kalyan, the Chief Architect and R2 Community Lead for Enterprise Engineering at Cognizant Technology Solutions, Pune. He's working with 24 plus years of industry experience in IT consulting, engineering management, and setting up SRE practices and technology COEs with various banking and manufacturing customers. His focus is always to help project teams in building highly reliable and resilient enterprise applications by adopting modern digital engineering practices that result in stronger business focus and improved customer satisfaction. His session title is Improving Resiliency and Reliability of Microservice Architecture with Istio Service Mesh.
Hello all, welcome to my session on improving reliability and resiliency, that is SRE operations of microservice architecture using Service Mesh. My name is Kalyan Dhokte. I am honored to present here at DevOps India Summit 2021. If you see, microservice-based application architecture offers very clear benefits, especially frequent releases, faster time to market, agile development, component-based design, highly used services. Also, easily you can scale up without scaling up the entire application. This reduces a lot of failure points and provides a higher availability. But however, wrongly designed any of the microservice architecture can make things more complex, and it also very difficult to understand what's going on in the microservice architecture and service-to-service communication. And it's extremely difficult to analyze any service-to-service communication and identify any performance bottlenecks. I'm going to talk about how you tie back some of the SRE practices to Istio Service Mesh, which provides a lot of features like service resiliency, observability, security, service discovery, traffic management, all those things. So before going into details, let me quickly introduce myself. As I mentioned, I am Kalyan Dhokte, Chief Architect and R2 Community Lead for Enterprise Engineering at Cognizant Technology Solutions, Pune. I am having 2 decades of experience in IT consulting, engineering management, setting up SRE practices and technology COE. So just looking into the agenda, I will start with a quick overview of SRE, and then I will dive into implementing microservice architecture with Istio Service Mesh, along with how can I improve with a project experience for improving the SRE operation using Istio Service Mesh. And then I will finally talk about Istio adoption challenges and takeaways. So SRE is talk about how you can make your application super reliable by implementing the SRE practices. Okay, let's understand what is the SRE. So it's a kind of a discipline and principles and practices that incorporates aspect of software engineering and applies them to the infrastructure and operation problem. The main goal of this to create ultra scalable, highly reliable software systems. So SRE is all about culture. It is not just running around the production issues and reactive problem management. But SRE is very proactive organizations. Let's see what kind of work SRE engineers do. So they are very much kind of front-loaded with automating a lot of processes, monitoring, reducing the noise, automate RCAs, conduct the production health check, readiness reviews with applications team. And they also set up principles and for monitoring and alerting and manages customer expectation. Also, they execute the incident response times and also responsible for creating blameless postmortem culture. So you can't make continuous improvements in your applications if your support staff is not comfortable on speaking up what they went wrong in production during the outages, and they should tell to the management without any fear. So this kind of culture to implement, you need a data, and how does everything is data driven. Like you want to scale up the applications, you need data, improving reliability, availability, understanding the performance of service to service communication, you require data. So if you see, the SRE best practices are implementation of DevOps principles with unique SRE specific extension. If you can see the side-by-side DevOps principle and SRE practices. The first thing we can see is reduce the conflict between dev and ops by breaking down the organization silos. SRE breaks down the silos by integrating dev and ops best practices and sharing ops with the work with the dev. So second principle is kind of accept the failure as normal and work towards reducing MTTF and MTTR. So SRE brings in SLO and error budget that encourages both dev and ops to keep system reliable. That's very important, to keep system reliable. And the third principle is more of implement the changes in production gradually. SRE reduces the cost of failure by incremental rollout strategies, like you can have go with the calorie releases or stage rollout or blue-green deployment, all those things. Then fourth is important principle is leverage tools and do a lot of automations for maximum productivity. So SRE practices implement that principle as a SRE puts a cap on amount of ops work and enforces automation for manual tasks, that is called as a toil. So and then the last principle is very important. You have to measure everything. Whatever the calls are happening, whatever the changes is happening on architecture, microservice architecture, you have to measure everything. So SRE enforces the robust monitoring through SLO and SLI monitoring and also provide actionable alerts and triggers. That is very important factor. So this is kind of overview. Then this is not a full-fledged SRE session. So I will just give the quick. This is a quick overview of SRE so that we can understand the principle. Now moving to the implementing microservice architecture using Istio Service Mesh. So what is Istio Service Mesh? So we'll look into that. But before that, when you start breaking up monolithic application into smaller microservices and smaller development team, we call it as a two pizza team sometimes, and it starts creating a lot more communication between service to service and between development teams. So that increases higher complexity and creates a lot of problems within the team and within the service to service communication. If you have large piece of monolithic software, you can easily add security as one of the module, code management as one of the module, and then resiliency pattern you can implement, instrumentations you have to add, and you are done with that. But in case of tons and thousands of microservices you have, which is deployed on Kubernetes platform, and then you cannot add it again and again. Correct? There are thousands of services. You can't add security, code management, resilience pattern again and again. So there is a need to add all these features only once without any code changes in the services. How that can be achieved? That is with the features what Istio provides, like security, telemetry, instrumentation, resiliency pattern without any code changes in services. So once you have smaller pieces of microservices, you are going to deploy in a Kubernetes platform that is more as a life cycle management platform, which provides a high resilient deployment and management kind of services. You can scale up and scale down those services. While Service Mesh is essentially about providing inter-application traffic and security management and observability. So overall, Istio helps to reduce the complexity of these deployments and ease the strain on your development team. So overall, Service Mesh provides uniform way to connect, secure, manage, and monitor microservices without any code changes. So now we can see how the reference architecture of the Istio. So Service Mesh is usually implemented. It's a key thing here is the sidecar proxy that we call it as NY proxy. Into each services, it is sitting between each services, and it captures all the metrics, logs, and even distributed traces, and able to send off all the data to the whatever your monitoring system you are going to choose it. So proxy also calls out the mixer for policy checks. Then it checks it kind of aggregation point which batch the data and send that to your monitoring system. So then there is a component called pilot. It pushes all the configuration to sidecar proxies and provides service discovery. Traffic management capabilities also it provides with the intelligent routing, and also it provides the service resiliency, different patterns like a timeouts, retries, circuit breaker, all those things. Then another component is very important, which is Citadel, is dealing with identity and security. It enables strong service to service and end user authentications and built-in identity and credential management. So latest version of Istio, if you see, the control plane is consolidated into a single Istio process, which provides advantage of seamless if you want to upgrade Istio to the newer version and do the patching and all those things can be taken care. So all these components are divided into data plane and control plane. So control plane basically all those which what I was talking about the pilot. It's a more from pilot, mixer, and Citadel, which is part of the control plane. So it configures the proxies and route the traffic. Additionally, the control plane also configures the mixer to enforce the policy and correct the telemetry. So this is the key a reference architecture of Istio Service Mesh that will be injected into your pod whenever you are deploying into the using the Istio Service Mesh. Now, quickly look into the different enterprise challenges what we face. I'm happy to share some of the project experiences where there are various challenges that my team has faced while scaling up the microservices, which are the statistics. If you see the statistics around 15 plus clusters, 100 plus namespaces, 500 plus services, microservices with the operations, and 100 plus kind of team members who are working on this the banking kind of project. And Istio provides the centralized governance platform. It does a lot of heavy lifting and reduce strain on developers. It provides the three main aspects of the security, then the operational agility and uniform observability. These three main aspects of the Istio, which provides all these reduce the strain from the developers point of view. So still, whenever we start with this architecture initially with the API gateway pattern, so we face a lot of problems, and then with the Istio Service Mesh, how we can overcome those problems. I will talk about that. So initially, the problem one is the number one problem, which is how to build efficient and secured service architectures. I need to understand what services I'm running in the, and then what is the real-time view of that services. Then I need to make sure that system is reliable. I can do the traffic shaping, basically the calorie releases, or it could be the blue-green deployment. Then I should be having the security configuration to be pushed to the different services instead of baking into the code, and understand there should not be a more latency, network latency, and all those things can be avoided. So that is number one problem, how we attack that problem and then provide the solution for this. The problem number two is how my dev and ops team collaborate. So what we have seen the principle of DevOps, where you have to break down the silos. So this is important, how I can do that using the service mesh features. So which will, I need to understand how the deployments, automating the build and releases, and configuring security and telemetry. Number three problem is again important, how to implement changes gradually. So if you have Calorie Releases or doing the changes gradually, there is a very less risk if any, in case of any issues occurs in the production, and then that can be published only some kind of set of users, very less set of users. And you can understand deployments, how you can do that, basically configuring the Calorie Releases, validation of webhooks, and you can deploy with the automation framework, which is can be virtual services or destination route. The problem 5 is important. Again, it's how is my service behaving. So whenever the developers quickly deploy any of the services, they should get the quick feedback from the performance perspective, and then they have access to the dashboards and metrics and distributed traces. They can quickly analyze the problem if there are any bottlenecks in the service to service communications. So it's important SLO monitoring, kind of a dashboard that will give the quick feedback to the developers. And then the last problem I can see is the problem number 6, how I automate root cause analysis, and I can reduce MTTR and MTTF. That's again one of the principle of DevOps. I can improve that, and then I can add as one of the my own SRE practices and integrating with some of the AIOps tools. So overall, Istio Service Mesh allows software platforms to do a lot of your applications heavy lifting and reduces the strain on the developer. It offers infrastructure standardization and allows security, traffic management, and observability challenges. And that can be help developers to achieve their goals, and then quick and releases and faster time to market. So we need to understand one by one all these problems and how I can overcome all these challenges. So moving into the problem number 1. So let us consider banking application, which consists of a set of services like products, then accounts and payments. The customer selects different banking products, like he can select that fixed deposit or loans or credit cards, and it verifies balance using the account services and initiate any payments to buy that product using the payment services. So this kind of architecture, what initially what we have created, which is using the API gateway pattern, and that architecture provides a lot of different benefits, like continuous deployment is possible of all the services. Any upgrade has to be done, you can do that independently with any new releases. Better testability it provides. Independent development teams we have. Account team is separately working, then payment team and product teams. Then also it provides traffic routing, and also depending on features offered by that gateway API gateway, you can offload some of the functionality from individual microservices, like some of the authentication, authorization kind of services you can offload to API gateway. And it also provides some request caching insight available from even gateway component that you can understand and monitor how my APIs are performing. But the most important drawback it also provides is that you are coupling the gateway tier directly into the internal microservices, which makes difficult in implementing any new changes in service. An API gateway can introduce increased response time due to the additional network hops. So if you see, whenever internal product is going to call any of the accounts API, it has to go first to the API gateway, and then from there it has to call that account API. So there is an additional network hops we can see here in the API gateway pattern. So it also creates additional possible single point of failure. The single point of failure there for API gateway. So overall traffic routing, I can be positive on that with the API gateway. Security is a tick mark, and observability is the tick mark. But the operations configurations related, if I need to push anything to and then update new services, there would be a lot of difficulties what I am going to face, a lot of challenges what and then there is a network latency and single point of failure. That's what we discuss now. But how can I move forward in this? We implemented Istio Service Mesh to move that architecture into the kind of Kubernetes cluster, and Istio Service Mesh is upgraded there, and then we move that entire architecture with the Istio Service Mesh. So we map back these gaps, basically the network latency, the single point of failure, and operations configuration updates. So because of due to sidecar proxy, it injects into this each of the pod. I can move the traffic around, and without moving the traffic outside the cluster. The latency problem is resolved as one of the services taking to other service next to each other. Maybe they are talking each other directly and within the cluster, with the same cluster, without any routing out the traffic outside the cluster. The outside cluster traffic is not can be removed, and also remove single point of failure, because ingress gateway, whatever it provides, it can be scaled up with the multiple instances as well. So we have multiple cluster and also zonal redundancy enabled, and control planes, and many control planes are going to be there. So it completely remove the single point of failure. So overall, I can see the API gateway exposes services as a managed API and focus transiting traffic for in and out. But if you see the Istio Service Mesh, it reduces that network hops related because of this internal traffic within the cluster. That's helped me to overcome this kind of a challenge, and I can see what different services. So another important factor in this is what kind of a workloads I'm running in the cluster, how I can know that, and how can get the real-time view of that, because lot many developers are releasing the services continuously, deploying the services continuously, but I am not aware what is the real-time view of that. If I want to induct new developers and then I wanted to give the training for them, that new person, I need to go through the documentation, but maybe it's going to be stale because there is a lot of more updates is happening. So you will get a real-time view directly. You can show this kind of a dashboard to developer, and Service Graph provides all these service topology and for any problem triaging as well. It shows the latency as well as between the service to service communications, and you can track that topology changes over the time, and you can do the drill down to the workloads and find out what logs are access logs as well as metrics you can collect from these services. So this is the problem number one what I faced, and then how I can overcome using the Istio Service Mesh. So this is the kind of practice you can create. That's your own SRE practice, and then implement in your project, so that that can be helped to achieve SRE and kind of principles and practices which could be meeting the SLAs and an error budget. So moving to next problem is how am I dev and ops teams collaborate. So we have understood the principle, that is the number one principle. I need to break down the silos between developers and the operation teams. So SRE is kind of a bridge between dev and ops teams. So whenever developers check in, then it check in the code in a branch, and then it trigger the build pipeline and trigger the release pipeline as well, and then it starts the deployment. So you have to write the automated scripts to do the pipeline executions, and then based on that, it deploys directly into the your Kubernetes cluster. So what we have done, we have created some automated scripts which will do that namespace creation as well as DNS configurations for the internal URLs. Also, we have configured automatically all the dashboard for any of the services, and then ingress gateway configurations related things that will be configured automatically with these automated scripts. So these SRE team, what we have, the two SRE engineers, those both of them are doing the all the automation and remove the manual tasks. Initially, there are 100 plus namespaces what we talked about. So those namespaces need to be created by running some kubectl commands. That is again manual task. But what we have done a lot of automations to configure seamlessly whenever you deploy the service, new service. All those initial the configuration in the Kubernetes clusters can be done very effectively and without any manual task. So that reduces a lot of errors with respect to virtual services and destination rule you need to configure. And then important thing is MTLS. So important thing why Istio is used is giving the mutual TLS. That is the benefit, as it's a banking application. The security is very important, and even during the service to service calls and even calls going outside the cluster has to be secure with the HTTPS, and within the service to service it should be used with the mutual TLS certification. So all this task is a kind of automated, and then there are validation scripts that will help. So overall, if you see developing and managing hundreds of microservices at a scale is a kind of a challenge for both development and operation teams. The objective of dev and ops teams often counter each other. So development team wanted to release any changes or any new microservice very fastly into the production, but the operations team wanted to put a break on that, so that they are very much concerned about the SLA. So causing the friction points, and that results in increase the handover cost and also the longer feedback loops between development and operation team. So continuous delivery process allows you to verify that your full project is in a workable and clean state before deploying it into the production environment. So Istio addresses all these challenges, providing good feedback mechanism to the developers with a quick dashboard they can see, and then also using the CI/CD tooling, they can quickly roll back in case of any challenges or any defects they find it during the validation or testing. Then it goes to the canary and blue-green deployment, where the set of specific users can be going to test that the new service, and then slowly we can migrate entire new service into the new version of that service into the 100% production users, that is the customers, end user customers. Now we'll see how that canary releases can be done using the Istio service, using Istio Service Mesh. So that's the next problem area where I can see how to implement the changes gradually. So it comes with the canary releases could be considered as a special case of A/B testing in which the rollout happens much more gradually. So the Istio provides the traffic configuration and can be used to perform the canary releases. So I need to set up some routing rules. There are two types of routing rules. I can do that with the fine-grained traffic percentage, or I can do that with the control traffic using other criteria, like I can do only open it for some of the test user or UAT users, and route the traffic for specific users to using the canary releases. So initially, what I need to do is I need to baseline the existing pod health, and with respect to all the traffic distributions, whenever the first criteria is kind of I can do that with a smaller percentage, so that only specific users can look into that and then do the testing. I need to make sure I need to have auto scaler configuration, so that whenever the load increases, it's going to scale up with the additional pods, so that it takes care of the baseline, whatever performance baseline I have. It is going to take care of that auto scaler configuration. if the service is observed is a healthy state and it is directed a small percentage of traffic, let's say 1%, then errors are continually monitored and healthier service pods are rewarded with the increased traffic until the new service is receiving 100% traffic for the old instances can be then shut down. So obviously, the ability to safely perform calorie releases depends on reliable and accurate application health checks. So Istio traffic routing configurations can be used to perform calorie releases by programmatically adjusting the relative weightages. You can do that adjusting and between the traffic between the service different service versions. So that's important how I can overcome this challenge incrementally. I can do that using these features what Istio provides. Moving into the resiliency kind of a problem, I need to configure resilient service need to be resilient. In case of any outage or something, it quickly move that the failing pods and from that any pod elastic pod what we have. So SRE can implement the resilient services as a kind of we can adopt that resiliency pattern. Istio provides failure recovery and pod injection features that you can configure dynamically at runtime. So ensuring that the service mesh can tolerate failing nodes and preventing localized failures from cascading to other nodes. So resiliency strategy can be adopted here. The pool ejection is one of the strategy. When a pool is pool of the instances or pod serving the client request, if the request is forwarded to certain instances fails, then Istio what it does, it eject that instance from the pool and certain sleep window is going to be there and it makes sure that only healthy pods participate in the pool instances. Then the second pattern is what we have the kind of traffic management. Simple configuration of service level properties like circuit breakers, timeouts, and retries can be easily configured here. And then you can move the traffic based on the percentage splits. Out of box, some of the failures recovery features to catch issues before they cause problems and making that calls more reliable. So that is possible with the service mesh features what is available, and that kind of help to SRE engineers to implement this resilience pattern. So outlier detection is one of the Istio resiliency strategy to detect unusual host behavior and evict the unhealthy host from the set of load balanced healthy hosts inside the cluster. So if you see in the diagram, the account kind of a pod which has an outlier detection kind of parameters configured in YAML files and as a kind of a deployment YAML files. The initial parameter is a base injection time. So if there is a 20 seconds, the maximum ejection duration for the host, let's say for the 20 seconds before it's evaluated again for the processing the request. So that timing you can set it here. Then consecutive errors, the number of errors before host is ejected from the connection pool. For example, if you have 3 consecutive errors while interacting with the service, Istio will mark that pod as unhealthy. Then there is the interval is another parameter, the time interval for ejection analysis for all those, let's say it's going to be a 10 seconds dependency, you can have that interval time. The max ejection percentage is another parameter, the max percent of host that can be ejected from the load balance pool. For example, setting this field to 100 implies that the unhealthy pods showing the consecutive errors can be ejected and the request will be routed to the healthy pods. Then we can configure even retries. There are some parameters that can be configured. One is number of attempts. I can put it as a 3 and then per retry timeout that also I can configure. So that gives me immediate, there should not be a direct end user impact because of the failure of any of the unhealthy pods. So I can move the traffic to the healthy pods and using this resiliency pattern what Istio provides. So higher microservice scalability can be also achieved having the multiple replicas of this control plane, and horizontal autoscaler is important here again, horizontal autoscaler. So that's how now you can see how I can overcome this problem 4, which is how to configure resilient service using this Istio Service Mesh feature. Now moving to the problem number 5 is more as kind of observability solutions that some of the Istio components provides, and that can be helped to generate the lot of telemetry data like metrics in order to provide overall component. Here is the Prometheus, which is a kind of add-on that you can add it into and configure into the the Istio Service Mesh. With the pre-configured server, it is going to scrap Istio endpoints and collect a lot of metrics, and then send it to your monitoring system. That is kind of if you have visualization tool. The Prometheus can be used to record metrics and track the health of microservices within the service mesh. So Kiali and Grafana are the visualization tool. It provides a different dashboard. It could be mesh dashboard, which provides an overview of all services in the mesh. Then another dashboard is called as a service dashboard, which provides a detailed breakdown of metrics for this service. Then workload dashboard can be also configured, provides a detailed breakdown of the metrics workload. And the performance dashboard, which provides the resource usage graphs and all those things related to CPU or memory and all those things for each of the pods. Then control plane dashboard, which basically monitor the health and performance of control plane of the Istio. So another important pillar of this SRE observability solution is distributed trace. So distributed tracing enables user to track the request through mesh that is distributed across multiple services. Istio does the header propagation through the client libraries. It has a client libraries that can be configured, like it could be a Zipkin or a Jaeger. Istio proxies can automatically send the time span, and the services need to propagate the appropriate HTTP header so that you can track all the spans and then correlate that correctly with the single trace. So that's the important factor for a distributed trace you need to configure. And Jaeger is used to monitor and troubleshoot all the microservice-based distributed systems, including the distributed transaction monitoring, root cause analysis, service dependency analysis, all those things. If you see, I can just zoom it over the dashboard here. You can see that a performance dashboard, which give me the details of memory where the spikes occurs and the virtual CPU. So then I can look into some of the Istio related distributed traces with respect to one of the service. I can understand the time span, and also I can get the more drill down for each component of these services, how the service to service communication happens, and where I can identify the bottlenecks. So Istio captures a trace for all the requests by default, but you can even configure it the sampling rate, that Istio. If you see that more strain is going to be there on Istio, and then you can configure the even sampling rate. You have to maybe set up some parameter trace sampling as an option, and then you can set the sampling percentage. So how I can understand how the service is behaving, how I can track the various golden signals that basically SRE engineers is looking for. It could be metrics, traffic, latency, errors, and saturation. That is the golden signal. SRE engineer always wanted to collect that data and then do the analysis and do the postmortem of any production outages. So Istio generates all that distributed traces, spans for each services overall, and call flows and the service dependency is another graph it provides, and then that can be easily, you can track that. If you see another dashboard here is the service workload. I can look into what are the incoming requests that's coming, and then it can be these incoming services, all those things. I can track all those things. But the important factor here is I can have a SLO dashboard as well. So I can track that services with the SLO dashboard and the success rate. So that's another dashboard you can look into. So now next phase, what I wanted to look into is how I can automate the root cause analysis so that I can reduce the MTTR and MTTPS. That's the important factor. Kubernetes Istio adapters to stream the data into my homegrown APM tool, and I can have customized SLO monitoring dashboard, which will have the color code green, amber, and red, and I can understand how the service is behaving. And I can also have the prediction algorithm here. I can look into using the AI ops kind of thing, and then do the prediction of where is going to be a problem in the future. So that is another area you can look into when you are implementing the AI ops. So AI-based anomaly detection integrates basically service mesh as a whole in order to track high-level KPIs as well as the most granular signals from each microservices. So pairing service mesh technology with AI-based anomaly detection solutions solve these challenges by enabling you to detect real-time incidents and can reliably reduce the time. So it's important that anomaly detection takes you have to plug in that all the data, whatever you are going to capture into time series database, and then you can run the certain algorithms and then find out the anomaly detection and suspect ranking of those problems. So there are various algorithms available in the market, and you can use that and create a solution for that. But the important factor here you have to keep in mind, your service need to be fully autonomous. I mentioned the service mesh. The large scale deployment is impossible to monitor manually. So that first consideration to make is to ensure that the solution can independently track and learn from the real-time data and understand the behavior. Another important factor is here is false positive rate. A lot of false positive rate comes when you look into the solution that have a false positive rate, and it leads to unnecessary noise, and it creates a lot of alert fatigue. So that's is kind of a headache because of this false positive rate. You need to minimize that noise always. And then correlation is another important factor. Finally, AI-based anomaly detection solutions should be able to automatically learn in the topology and for that service mesh and connect the dots. So it's important. The automated machine learning, what we have used here is the Python skyscraper learn algorithms to correctly point out the root cause of this problem and occurred. And then I can see that the automated suggestions for the root cause analysis. I can using that kind of some past experience data, and then I can get that root cause analysis solution for those anomaly. Directly suggestions can be provided to the SRE engineers. So this is important area where you can do that and go to the higher level maturity of your SRE dashboards, so that you can use the AI ops, imply that into your projects, and then do the automated root cause analysis. Now I am going to touch base on some of the Istio adoption challenges. Now it comes to the adoption challenges. So basically, with respect to traffic management problem, initially there were many requests are getting rejected due to various reasons. But you need to check the response flags in the access logs. It could be the upstream not available and route is not available. Those kind of flags are there, and based on that, you can identify what is the root cause. There could be incorrect TLS configuration many times, mismatch. If you set a global flag, something different in the policy, and the destination rule setting flag is different. In that case, it is going to throw the 503 error. Many times, it also throws 404 errors due to multiple gateway configured in your Istio Service Mesh using the same TLS certificate. And configuration of those changes to traffic routing rules takes a longer time for propagation sometimes, and that also creates the problem during the traffic management. So then the next is the security problem. You need to check the control plane is distribute authorization policies correctly to all the proxies. That's very important. And then there could be some, because of that, there could be some keys and certificate errors that you can overcome. Then configuration validation problem is important. There are admission webhooks you can configure, and which is a kind of special kind of webhooks that can be validated due to missing configurations, bad certificate, or network connectivity problems. That will produce a lot of error messages which cause the pods to fail to start up. Then the sidecar injection problem is another area where if the sidecar is not injected correctly, then it is not going to pull the data metrics and logs, and then it's going to be I think it's because of sometimes the certificate is not signed by correct authority, and you are using the self-signed certificate. It throws the errors. You have to understand the certificate issue, and then verify that the web configuration hooks matches the root certificate what you have mounted on the Istio pod. So another area could be no endpoint available. That kind of errors happens in a deployment status. This is because of Istio D service, which is an important service, is control plane service, which is not available or not ready, and that kind is going to throw that kind of error. So observability problem, it sometimes what happens, missing an incorrect metrics, it will be collected by service because of sidecar proxies exist sometimes and have been injected, not injected properly. There could be a missing Grafana output due to date time mismatch as well. You have to verify that time synchronization service is correctly configured and in a Kubernetes cluster and your web client machine. So that's to summarize overall in these sessions. The key takeaway is definitely it is useful for you to implement in your project. You can create your own SRE practices using the Istio Service Mesh features that provides in-depth view of microservices availability and diagnose and debug the problem. That's the important understanding you can have and then implement that SRE practices in your project. There could be integrate Istio, the whatever the observability data, you can use that Istio feature to do the using the native add-on components, or you can integrate that with one of the AI ops tools with and then work towards reducing MTTF and MTTR. Istio Service Mesh provides also the transparent language independent. What we have understood is you can do that very flexibility and then automate network security observability functions without any code changes. So overall, if you see the SRE best practices can be implemented and then all the DevOps principles for your development and operation teams to make applications highly reliable and resilient with the respect to the changing business needs. If you can concentrate more on changing the and then doing the faster time to market, and overall new business innovations can be achieved in a very less time. So the Istio takes care of all those aspects and the features, and then you can create your own SRE practices to understand and improve your overall SLAs and whatever the error budget you have, you can work in that error budget. So that's all from my side. Thanks. Thank you very much. And you can reach out to me on Dhokte as a Twitter handle. You can post the questions even the session. Thank you very much.